26F, Codeforces around 747, 674, div 3. This is a question. Okay. So the explanation for the question is, for an example, consider this string. Now, if we substitute the question marks with the characters A, B, or C, we'll get 9 possible strings because the number of question marks is equal to 2, and for each question mark, we have 3 choices. So the total number of choices is 3 bar the number of question marks, that is 3 bar 2 is equal to 9. These are all the choices we have. Now, in this string, how many subsequences A, B, C do we have? That is, since there is only one B, that will be the B we want at the middle of the string, and the number of subsequences A, B, C are uh, this C would be in the end, and any of these two A's could be the first character of the string. So there will be two possible. In this string, we'll have 2 into 2, that is 4 possible strings subsequences A, B, C. Here we'll have 2 into 2, 4 again. Here we'll have 1 into 2, that is 2. Here we'll have 3. Here we'll have 2 into 2, that is 4. Here we'll have 1. Here we'll have 2. Here we'll have 2 again. So the total number of subsequences ABC formed from all the possible strings are 10, 15, 19, 20, 24, and this is the answer that is given in the sample test case. Now, an observation we draw from here is that for the same indices I, j, k. So if for example we pick up this triplet I, j, and k, for these three indices, two different strings can give the same triplet ijk. So in a sense, what this means is the same ijk triplet may be counted multiple times due to the question marks present in the other indices. So here, for example, we had a question mark here and here, right? So since we had a question mark here, for two different question mark values, we got the same string because this question mark was not a part of the three indices that were being considered while considering this particular triplet of indices ijk. So the way we model this is with a dp, where dp0 of I is equal to the number of subsequences ab ending at I, with 0 number of question marks involved in the creation of the subsequence AB. That is, A would be a organic character, B would be an organic character. None of them are derived from question mark. Okay. This dp1 is 1 question mark, dp2 is 2 question mark. That means that in AB, originally both were question marks, right? And called dp of I is equal to the number of subsequences ABC ending at I, right? So the answer, it is very easy to see that the final answer would be the summation of dp3 dp4 up to dpn, that is summation of dpi I is equal to 3 to n, or if we handle the edge cases correctly, I is equal to 0 1 to n. Okay, so the transition for our dp would look like this, that dp of I is equal to, let's say for example that um, none of the indices a, b, I, j, k, none of them none of the indices I and j, none of them were originally a question mark, right? So we have already calculated this via dp0. So since both of them, none of them were question marks, and the total number of question marks in the string are NQ. So the number of subsequences ABC ending at I would be given by ending at I with zero question mark still would be given by if str is I is equal to, if the ith character we're considering is equal to C, of course. If the ith character is A or B, then for sure we will not be able to get any subsequence ending at C, subsequence ABC ending at I, since these character the kth character is already A or B. We won't see, so this is not possible. For that case, the answer would be dp of I values would be 0. Considering the other two cases, that is when stri is equal to 2 or stri is equal to question mark, for this particular case, uh, for this particular case, here we want that the number of question marks in the whole subsequence ABC should be 0. That is, all of A, B, C, all the indices I, J, K should have been the characters A, B, C should have been gotten organically. So this is it. So from this we calculate the number of ways to get AB organically from the indices 0 to I minus 1, and this is to get this is and C is of course we the ith character is C, so we are picking that by default, and 3 par NQ is the number of question marks, the number of strings which will give us this particular ABC subsequence ending at I with zero question marks being substituted. So this is this part of the term. This is when one of A or B was a question mark. C is coming organically, of course, and we have Q minus 1 question mark still left in the string. They might be here also. We have Q minus 1 question mark still left in the string, so we have total 3 par n Q minus 1 options for this. So this explains this term. Similarly, this term is when both of A and B were question marks, so we have NQ minus 2 question marks left. So this is it. And if the ith character itself is a question mark, then then of course we'll have n. So if A, B both were organically derived, we'll have NQ minus 1 question marks left to be filled. So the total number of subsequences obtained from this is this. Similarly, these two terms are also there. So having a look at the code, this is the code. We are calculating the total number of question marks here. dp0, dp1, dp2, we're maintaining these three arrays. And populating it as such where if the ith character is A or C, we can't get any subsequence A, B ending at I, since the ith character is not B. So then all the DP values would be 0. If the ith character is B, then and B, so since B is obtained organically, we know that if DP, we need to calculate DP 0, that will be, for that even A should have been organically derived. So there are a number of such subsequences AB. Similarly, there are num-q's where number of question marks still, num-q is the number of question marks till I minus 1th index. And similarly, dp2 of I would be 0. This is easy to see. And by PDP, we are maintaining the prefix sum because here we have a summation. So we would use a prefix sum of all these. We'd use a prefix sum of all these values and multiply it with this term for faster calculation. So yeah, this is us maintaining the prefix sums. And finally, moving on to the calculation of dp. If A or B, so as we discussed, if that the ith character is A or B, then dp of I would be 0. If it is C, I've used this particular transition. This I've already explained the logic, so this is it. And one thing to keep in mind is we need to use mod addition, since the values can be very large and it is mentioned in the question, and we finally print the answer. Yep.